In this example, we have that for a climbing wall, a guy wire R is attached 47 feet high on a vertical pole. Added support is provided by another guy wire S attached 40 feet above the ground on the same pole, so 7 feet below the initial one. If the wires are attached to the ground 50 feet away from the pole, so that's the horizontal distance there, we want to find tangent of alpha, where alpha is the angle measure between the wires rounded to 2 decimal places. So we're going to try to find what the ratio of tangent of alpha would correspond to. A couple notes about this problem. Note that alpha in this triangle here defined with S and R, alpha is not within a triangle that is a right triangle. Therefore, I cannot just define that as the opposite side and the adjacent side because it's not within a right triangle, so that doesn't work really for us. The other thing about this problem is that even though it does ask us to find tangent of alpha, finding alpha is not necessary. As long as we can understand how the ratios work, all we need is tangent of alpha. For the other angle measures that are presented here, though, from this diagram, we have that beta is corresponding to the angle measure from the horizontal line, so from the ground up to the value for R. So that means we really have a triangle, a right triangle in particular, with beta, where we know the opposite side for R is 47 and the adjacent side here is 50. We also see another smaller right triangle involving the side length of S, but the angle measure that goes up to S is not beta and it's not alpha. It is actually the subtraction of those two. So we have another right triangle here. In this case, the angle measure is actually beta minus alpha. And we know the opposite is 40, the adjacent is 50. Well, I know beta minus alpha, I know beta, and I want to figure out alpha. We do have the identities for tangent, the sum and difference identities that can allow us to start to connect these. Specifically, since I see beta minus alpha, might as well use tangent of beta minus alpha. Tangent of beta minus alpha from the tangent difference identity would be tangent of beta minus tangent of alpha divided by 1 plus tangent of beta times tangent of alpha. With this identity, we can actually plug in values that we already know. I know tangent of beta because beta here has an opposite of 47 and adjacent of 50. Therefore, tangent of beta is simply 47 over 50. I don't know tangent of alpha because that is actually the question. That's what we're trying to solve for. But I know tangent of beta in the denominator should also be 47 out of 50. I do actually also know the left side of this equation. Tangent of beta minus alpha, that's the opposite and adjacent within that second right triangle. I know the other side should be 40 over 50. So really what we have here now is an equation where I have one missing value. I have tangent of alpha that is missing. Technically it shows up a couple times, but really this is now an algebra problem. If I move this down so I have a little bit of room, you could, if you wanted to, even for the time being, substitute tangent of alpha and call it x. For some, that will clean this up and make it look a little bit easier. 40 over 50 equals 47 out of 50 minus x divided by 1 plus 47 out of 50 times x. This is no longer even a trig problem at this point. All I'm doing is a little bit of algebra in order to solve for x. We'll take a couple steps, but we can work through this. If I multiply both sides by the denominator on the right, I can start to maneuver this around. And what I can actually do to make this a little bit easier, because I see all of these have fractions of 50, I'm going to multiply by that, I think. Do I want to? So that will give me 40 over 50 times 1 plus 47 out of 50x is equal to 47 out of 50 minus x. If I distribute there on the left side, I will get 40 over 50 times 1 is 40 over 50. And then 40 over 50 times 47 over 50. That will give me a denominator of 2,500. I believe 1880. Yeah. That still equals 47 out of 50 minus x. I will move the constant terms over to the right side, and then I'll move the variable terms over to the left. So I have 1880 over 2500x plus x equals 47 over 50 minus 40 over 50. These terms will all combine pretty well. 1880 over 2500x plus x will add another 2500 to the numerator. So that will have now 4380 over 2500x equals on the right side 47 over 50 minus 40 over 50 is 7 over 50. I can solve for x now as 7 over 50 times 2500 over 4380. Or x is approximately 7 over 50 times 2500 over 4380 equals about 0.0799. Yeah.